This question actually looks to most people to be harder than number 14, but to me, this is a really great question. If I had to choose between those two, I would definitely spend my time on number 15 because I can arithmetize. It's confusing, there's a weird equation, but there are some really easy ways that we can kind of deal with that and visualize what's going on in a much easier way. Whereas number 14, you gotta just like do a ton of algebra, and it's really slow and very prone to mistakes. So what we're being asked here is to kind of understand how this equation works. And if we think very intuitively about algebra, we might be able to do this without a lot of work, but I don't trust myself because I'm on question 15 out of 15 in the multiple choice part of this section. It's supposed to be hard. There are going to be things that kind of are meant to defy my expectations. So I'd rather prove my answer with numbers. So how would I do that? Well, let's take Roman numeral 1 here. A temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. Now, if that seems really crazy to you, then this is a great example of how arithmetize can make things easier. Start with a simple number. Start with something like F equals 32. Now, that doesn't seem like a simple number, right? Well, except in this particular equation, 32 degrees is like the ideal situation because watch what happens. C is equal to 5/9 of 32 minus 32. Well, 32 minus 32 is 0, so 0 times 5/9 is 0. And if we know Fahrenheit and Celsius, we know that, yes, 32 degrees Fahrenheit is 0 degrees Celsius. But you don't need to know that for this question. That's not what they're testing. But this is a good example of how arithmetize isn't really just about picking like 0 and 1 all the time. It's about picking the most lazy number for this situation. So in this case, when F is 32, we get a very convenient C being 0. All right, let's write the C. So why does that help me here with Roman numeral 1? Well, it really doesn't until I just treat Roman numeral 1 as an instruction. Because they're telling me to increase the temperature by 1 degree Fahrenheit. I can do that really easily. Now F is 33. What happens to the Celsius temperature when I increase that by 1? Well, again, this is not that hard of math. 33 minus 32 is 1. So 1 times 5/9 is 5/9. So look at the change. The degrees Celsius increased from 0 to 5/9. That's an increase of 5/9 degrees Celsius. So yeah, it's a weird fraction, but it doesn't matter because I'm able to prove it pretty easily with some zeros and ones. That's awesome. So that's got to be true. So now I'm really just looking at, well, if I can prove either of these other two, if I can, it really comes down to number 2, right? Because if 2 is true, then it's D. If 2 is false, then it's A. And so B and C are not even possible answers at this point. So literally, I don't care about Roman numeral 3. So this is good, like kind of reasoning it out. But let's try Roman numeral 2. A temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. Uh-oh. Well, we've gotten from fractions to decimals here, but let's give it a shot, right? So there's a couple ways to handle it. I would say let's stick with the numbers that we had before, right? So 0 degrees Celsius is equal to 30 degrees Fahrenheit, but now let's change it. Let's increase 1 degree Celsius. So 1 is equal to 5/9 times some Fahrenheit temperature that we don't know minus 32. Well, in order to move a fraction, we usually multiply by the reciprocal. So, okay, 9/5 is equal to F minus 32. Okay, so here's what we're going to do. Watch this. This is very clever. If we just add 32 to both sides, my normal math instinct kicks in and says, well, you got to now add a number to this fraction, but I don't really want to touch that 32. I like it as a 32 because I'm interested in the increase in my Fahrenheit temperature. And 32 was my original value. So if I write this like this, 32 plus 9/5 is equal to f, then I can see there's my 32 that I had before when the 0 degrees Celsius was the equivalent. So the thing that Roman numeral 2 is really asking about is the increase in the temperature. I have the increase right here, 9/5. So I need to ask myself, is the value 9/5 equivalent to 1.8 degrees or 1.8? I don't know what the best way for most people is going to be here. You might just do the division. There's lots of ways to think about it. We could just take 9/5 and turn it into a division problem. So 9 divided by 5. Well, 5 goes into 9 once, and then we can do some long division, right? So minus 5, and that gets us 4. So what do we do? How do we deal with that? Well, we add in a 0 and a decimal place. And now it's dropping down, and now we're asked how many times does 5 go into 40? Well, it goes in 8 times with nothing left over. So there it is, 1.8. That's true. D is the answer. So is this kind of messy? Yeah. But I don't think it's any less messy if we do it with just like pure brain power and just like try to think it through. And I think that is really hard to see what's going on. Whereas if we have numbers, we can hopefully prove our answer and be much more sure about what we're doing. I think Roman numeral 1 is definitely easy to get with arithmetize. No doubt about it. We can pick an easy number, 32, see what's going on with the temperature, and we're told to increase it, so it's very easy to see that increase. And if we just were able to prove Roman numeral 1, well, we've already got a 50-50 chance at a very, very difficult question. You've increased your odds. So if you can't figure out how to prove number 2, just guess at that point. You've still done really good work, and you have a 50-50 chance. But this way of using arithmetize does come up on some hard questions where we're asked not to understand the value, but to understand a change in value. And so what you really want to do is understand, like, okay, I don't have to just pick one value for my f or my c or my x. I can pick one, get a baseline, and then follow the instruction. How much am I supposed to increase or change that number? And then change it by that number and see what happens next. That's a very useful way of thinking about arithmetize, and it could really save you on some hard questions. So I hope that you at least can take that away from this explanation.